I want to thank Jim and Mark for this opportunity. I really am very grateful. I did have a wonderful time with Mark, and we are missing Mark, and that's the way it goes. He's a terrific leader, and our loss is your gain. So I'm sort of at the end of the day, so I thought I would, probably your brains are near full, if not already full, from two terrific talks by Peter and Marty. So I thought I would try to sort of focus this in a bit. My job was to close with policy. So I'm going to suggest to you what you've heard from the first two talks, if I can borrow Marty's phraseology. I'm going to suggest to you there are two basic frameworks that define robustness so fundamentally differently that I'm not sure that they can be brought together, and that's why I've put the connector between these two, economics and sustainability, unlike perhaps a science of or a physics of sustainability. I'm not sure you can use a preposition between these two words, because that's not clear to me that economics is ready for the shift that's needed on this score. Now, that's going to get me in trouble instantly, but that's what I decided to do. And so I'm going to present to you what I think is two frameworks for robustness that have such different assumptions about how to become robust over time. And they're going to try and grapple with a problem that we have, and I'm going to use the energy case for this, that we're going to have to probably make a choice between these two frameworks. I'm not convinced that it's entirely dichotomous, but I do think this is going to be one rough choice for us. And I do want to just say, before I get to the end of all of this on the policy side, if you think you're going to convince a large body of people, never mind several governments around the world, to make a change, given the kind of ubiquity of energy that Peter indicated, if the policy question is so complicated that it looks like you have to be some sort of very special hybrid human being in order to make the choice, politicians will leave the scene. And I would offer to you as one small piece of evidence in that regard, you can measure about 6 weeks ago, the only treaty that was ever negotiated by humanity to deal with the problem I'm going to suggest, climate change, lapsed. And we had 18 years of trying, and it lapsed. So this is not easy, and as many of you know, the signals that we are receiving about this issue would suggest that we're running out of time to make a decision. So I'm going to take the plunge, and I'm going to go after a case. There are two methods of robustness to get there, and I'm not sure we have time to find out if we can meld the two together. So I'm going to use an older paper by John Peasy from the World Bank. Marty published an earlier paper with this gentleman, and this was an argument that was going on back in the early 90s, trying to figure this out, where economists were trying to understand the environmental footprint of the impact of thinking economically. And Peasy raised the question about the difference between what economics sees as the pathway to, if you will, social robustness, which is optimality, against another forming framework, emergent framework at that time, called sustainability. And if those of you who've had fun with economists know that economists, like theoretical physicists, don't believe that data tells you everything, and therefore you can always spot a good economics argument because the axes will be very ill-defined, almost unmeasurable. And so here you are with optimality. We have welfare. What is included in welfare? Well, a lot of things and whatever. There's a minimum level of welfare. Do we know what it is? Well, not necessarily. But what we could see is that we could try to optimize our economic gains in particular, but that may put at risk the ecosystems that are required in order to produce that optimality. And that may mean that eventually those ecosystems would at least experience significant problems, if not collapse, and those significant problems could undermine the long-term gains, which prompted a conversation between, I won't get into names, but one person and another person, one of whom is an economist, and the economist is asked the question, well, what happens if we follow optimality and the basis for human life collapses, to which the economist replied, so what? And the reason for the so what is if you've gotten everything that you can, what's wrong with the outcome that we got everything we could? And now I'm a recovering economist, and I'm taking jabs probably inappropriately at. I love economics. I love to teach economics. So I just want to be very careful about all this, but I do, and I think it has a great deal to offer to us. But I think that there are some challenges between the idea of robustness in economics, which is to optimize, particularly around those things that we can find economic value in, against an alternative paradigm of sustainability, which might mean that we go much slower, we may be less wealthy, and a lot of the argument that took place around climate change is around essentially these kinds of choices. So I'm going to characterize the optimality case, and then I'm going to characterize the sustainability case. I think they're two fundamentally different ways of reasoning. The optimality case, I'll give you a small metaphor that may or may not be useful to you. Most of us, when we get in a car to drive, on the driver's side, we sort of drive automatically. But if you dare and look below the steering wheel, you'll notice that there are some pedals. And you probably use them, okay? Economists like that rightward pedal, the one that's the accelerator. They're not fond of brakes. And a solution always, if possible, is to find an equilibrium state in which you don't have to stop. Growth for economics is fundamentally important to prosperity. As much growth as you can get that's economically efficient, you should go after, okay? To me, sustainability in a metaphoric sense, it's one of those that looks below and it sees the brake, and then it sees maybe if there's an emergency brake or lever there. Seems to me sustainability is more concerned about whether there are signals in physical or other systems that tell us that there are speed bumps along the way, that there are stop signs along the way, or that there should be. And that these two different ways of thinking indicate then that what would be robust from a sustainability point of view, you should pay careful attention to the speed bumps and to the need for brakes and to the need for stop signs, and you should slow things down when you're getting certain kinds of signals. Economists would like to see us innovate around. I mean, build around the current speed bump, build around the current stop sign, find highways that don't require you to stop, and try in that way. I'm not sure. I mean, I think there are ways to learn from both. Well, there's certainly ways to learn from both, and I think there are times when there are ways where we can, in that learning, we can have, in a certain sense, both. But I do think we're approaching a point where we're going to have to choose between our definitions of robustness in the spirit of Marty and make choices. So, okay, so I'm going to start off with optimality, and I'm going to give you a picture of optimality. It's the end of the day, so I'm going to give it to you in hopefully easier, more digestible formats. I want to tell you about our world, okay? Optimality works. It worked unbelievably well through the industrial era. And there is ample evidence for it, but I'm going to give you 3 simple examples of how powerful and effective optimality is. So to do that, I'm going to take you to an intersection of New York City that you might know called Times Square. And this is New York City in 1890, 1902, 1921, and today. The difference between this way of life and this way of life is called progress. There is absolutely no doubt, okay, that everyone wants to live here and doesn't want to live here. It took us about 100 years to build this growth model so that we can now have a way of life that has this kind of energy density gathered in an urban settlement, okay, from here to here. This model is a very powerful model, and it has been exported and it has worked. So Mark indicated we've been active in Asia. I'm going to give you a couple of pictures from Asia. This is Seoul City in South Korea in June of 1950. It's 1 month before a war will break out on the peninsula. This is Seoul City for the next couple of years after that war breaks out. And this is Seoul City today. In 50 years, this model of rapid growth that could achieve the kind of economic benefits that were found in the US was rebuilt in a part of the world that was devastated by war. So that's a half-life, right? You could move things twice as fast and after a devastating war, okay, in that period of time. And I want to give you one more. This is Shenzhen in the People's Republic of China in 1980. This is a community that is largely dependent upon fishing as commerce, not, it's largely a community dependent upon fishing. And at the time that this photo is being taken, you're in at around 100,000 or so people, okay? This is Shenzhen today. 12 million people, 2 New York cities, built in 30 years. Please.
In fact, I was in Shenzhen in 1990 even. And
so you still,
it's
still
so
booming.
It's really just 20.
That's right, that's right. Okay? The point I'm trying to make, obviously, is the pace at which we can build a growth-based model of robustness or prosperity is advancing at speeds that I think even we on Earth sometimes have difficulty imagining that this kind of thing could happen this quickly, okay? But this is how our world is now working. And this is not going to be the end of the story. You can imagine this kind of development pattern happening still more throughout the world. It's happening in Asia, the fastest growing economic region and the fastest growing energy consumption region. You're going to find this happening more and more throughout the world. And if you consider as one simple way to image the success of this model of economic growth, I'm going to give you, I want to take one moment, because sometimes when we talk about China, there is this perspective on China that is sort of top-down, you know, that Shenzhen was designated to be this. If you would please, it's a way to think about it, but if you would please just talk to folks in Shenzhen, the view that you'll get from the folks in Shenzhen is that the government designated them as a special economic zone, which sort of said, you know, anything goes and we're getting out of the way, okay? And locals had to do this, and locals had to figure out in the sense of how to adapt to rapid change like this, how to make things work, how to have those markets come up without almost any assistance from the center. So this is really much more of a market-driven model than one would expect. Okay, this happened. It's a speedy process, and we're going to end up in India toward the end of this, where we've just returned from a study visit there. It's unbelievable. Okay, so now if you then try to imagine what would be a portrait of our success in the last 100 years or so, and I'm going to use the older version because I haven't had time to update my slides, but you probably have seen the image that I'm about to show you. NOAA took a snapshot of our world at night by taking the same hour of night with satellites across the world, and you get a picture that looks something like this. Now, what I'd like to ask you, of course, and there's too much light scatter for you to see the light scatter, but what I would like you to consider is that if you were a planet in our system, and you were orbiting around Earth, what you would notice is that something dramatic happened on a planetary scale by human activity in roughly 100 years. This image gives, I think, a fairly helpful idea of how much impact we are having. And this impact is still incomplete. You can see that sub-Saharan Africa has still seen far less of this model penetrating than other parts of the world. Parts of Asia and Southeast Asia have not seen as much. Hopefully we won't see much here, but you know, never can tell with the Amazon. In any case, there's a likelihood that this is going to fill out, but I think as Peter nicely pointed out at the front end, this model depends upon something approximating energy as, if not, I've had too many economics courses to make the phrase free work, but that it was very cheap energy the model essentially did require as a backdrop that the tank was nearly full, the energy tank was nearly full, and it was eminently affordable. And I think for what we have so far today, this robust model depends upon cheap energy that will be widely available. And you can now ask yourself, what's it going to take to fill out this model beyond where it's gone so far in 100 years? And so to ask that, if we're going to do it with the energy-based industrialization that's also highly affordable, this is where we are currently. And if you were, and Peter did this in his slides, if you were to say, what if you migrated the industrial way of life, okay, as a ubiquitous way of life throughout the world, what would it take, at least on the basis of the energy systems that we now depend upon? And Vaclav Smil did the work on this, and so the migration from this world to this world, we're only going to need something, on the order of 6 or 7 times the energy production that we now have in order to make this work, okay? And we're looking for that. We're busy, we're trying to make our technologies better, we're trying to find new, both of existing resources like natural gas, we're trying to find new reserves of those gas that we can use. This is the sort of, I think, hunt that we're going to be on in this model. Okay, so let me now go to the other side of the coin. This is a model that I think is interested in robustness, but it defines robustness in a different way. It defines robustness as not having to answer the question, well, what if what we do removes the basis for human life? The answer, so what, is not acceptable in this model. Instead, you're supposed to figure out how to prevent that, okay? And so sustainability is looking for what would be the stop signs or the speed bumps that we should be paying attention to. And in that context, sustainability now currently is often aligned with the policy discourse on climate change. And you're going to see these two, they have been married for some time, and I think they will continue to be married. So let me go through very quickly. This is not, I'm not trying to argue the case one way or the other. I am trying to illustrate a reasoning that would say this is important information and we need to act on this information, okay? It isn't that the optimality model, what I'm about to show you, isn't interested in this, but there is a reason why this won't be compelling enough to change, and I'll go over that in a moment. So to do this, I'm going to use one of the models. Peter said earlier, it seems too model-driven. I'm going to use one of those models that comes out of the UK Met Office, and basically what you're going to see is on the left-hand side is going to be the business as usual for 100 years. That's if we don't change significantly the vapor trail that we're leaving as part of our development process. Our economic growth worldwide is about what it's been. Our population growth slows down a bit on this, and our technology improves a bit. This is a so-called A1B scenario from the Intergovernmental Panel on Climate Change. It has some improvements over where we are, but it's basically a business as usual build out. And then over here, this is going to be, the E1 scenario is an effort to back off from the release of those emissions, and the intention is to try and reduce the risk that is associated with that. Now, this is a model-driven answer that I'm about to give you, so the risk depends upon how you model risk to get the result that you're going to see. But I think it does illustrate how folks think on the sustainability track. And you're going to see in this an effort to hit a 350 parts per million by volume of CO2 equivalent gases that come from human activity, that you're going to try and hit that number somewhere in the middle of this century, the clock is ticking, and sustain it through the end of the century, okay? That's essentially the challenge that's going to be presented on the right. This is regarded in the sense Marty used earlier, precautionary principle. This is in the spirit, okay, of trying to convince humanity to take steps to reduce the risk of what is going to happen on the left. Okay, so quickly, 50 years into the experiment, the warming process has begun to take place. Of course, it's going to happen in the poles in a most pronounced fashion. And you can see the spread of temperature at this point that is going to be, as this model would suggest, that we're going to have to then figure out how to adapt to. Because we were talking about Nepal, and this is going to be a bit rougher ride if you're living in Nepal than it will be in other places because of the risk, if this risk comes true. And then there's no way out of a warming process in these models throughout the 21st century, but you're going to see the major problem here. You'll see less of it here. By the end of the century, yes. Okay, so it's a big problem, and I want to just mention this particular piece of the problem here, Greenland, which I'm sure all of you know. The stack of snow and ice here is one of the most important in terms of creating a balance for temperature on our planet, and this kind of warming scenario is obviously very problematic. And I'm going to just briefly mention another aspect that comes with sustainability in this regard. This process of risk is not one in which everyone is going to share risk equally. Not only is Nepal going to be, if we go through and the risk bears out, not only is Nepal going to be a greater risk than other parts of the world. Generally speaking, humanity that's along coastlines are going to be more at risk from sea level rise, and those who have the least ability to adapt, that is to build whatever it is. The U.S., New York City with the storm Sandy, we did build a wall, and we built a wall for a 200-year storm, and no one can say that storm was because, okay, the models are nowhere near any kind of predictive capability for that. But it does give you an indication of the kind of challenge of trying to protect yourself against this kind of risk. So the reason that sustainability has often had built into it the issue of both present and intergenerational equity is because of the concern that when we risk to exceed the speed limits and run the stop signs, that when we do that, that we are forcing change on populations that have lower resources and in this sense may have greater problems trying to deal with the risk itself. And so where does that water go? If it happens. So this is the interesting, there was an anomaly, no one knows, but normally, since 1992, the extent of ice melt in Greenland has been shrinking. We're now down to about 40% in the summer that's still entirely covered. But there was this oddball event that occurred on July 12th where over 90% of Greenland had evidence of melt. And you're going to hear when the IPCC issues its next assessment that there's going to be more concern about this problem. It would appear that the modeling that was used is, at least against the data that we now have, the modeling that was used may have understated the risk. Again, it's still a risk, and the models can be dead wrong. And but this is the kind of problem that we're going to be addressing. And then this is evidence that this ice melt phenomenon is, so this is an effort to plot how much of the area of Greenland that's subject to melt during the summer period, and you can see against a baseline for the last 30 years, and then you can see what's been happening recently. Again, these are far too short of time frames for us to say. It's instead an expression of a risk that a sustainability-minded argument embraces, that this is risk and we ought to do something about this risk. Where does the water go? That's why I said about the coastal populations, and one of the regions that's most at risk is Bangladesh because of the low-lying area of the region. So the World Bank is now in a project because of this possible loss of about home for about 17 million people. If, again, the risk is borne out, and where do you, so the World Bank has now set up a program in Bangladesh that is trying to figure out how to do adaptation on this kind of scale, okay? So this is the sort of issues that so what would it mean if you were thinking sustainability in these models? A long time back, we published a paper back in 1998 that the IPCC has used where we basically tried to figure out what is a reasonable metric. It's not entirely, it doesn't account for everything, but a reasonable metric that we would have to hit in order to, as best we understand things. This is going to be human beings looking at our knowledge, deciding on the basis of our knowledge whether we're willing to take risk A or risk B. I'm going to go through the two sets of risks in a moment. This one says, what would you have to do to turn off this risk? Basically, the planet came with the capacity to absorb about 3.3 tons of carbon dioxide per person per year at 1990 population. That's the for what we know at this point, that's how much we can recycle. So if you want to hit something that will get you by mid-century at the 350 parts per million by volume, per capita emissions have to be around 3.3. Who needs to make the shift? Not difficult in this graph to figure that out. At 19 tons per person per year, the U.S. is the most carbon-intensive civilization on the planet, but nearly all of the industrialized. The model of economic growth that says this is a definition of success, of robustness, it gives you the ability to adapt to the future because you now have the kind of economic and infrastructure capabilities to deal with that. All of those folks that are on that model success stories, okay, are now the places where the biggest reductions need to take place if you're going to look at this from the perspective of sustainability. Okay, so there's no way that you can map this out and say we know for a fact that this is, I mean, I thought Peter's opening was beautiful. I loved it. On the energy side, I think it establishes exactly what is the character of the problem that we're dealing with. But now we have to answer a second question, and that second question is where the unknowns, rather than the knowns, are all over the map, okay? And while we need to work hard on trying to reduce those unknowns, we're probably going to have to make choices under uncertainty in the manner that Marty framed in his piece, okay? So images of what it means to take risks in the BAU scenario, images of what it means to take risks in the sustainability scenario. Okay, so here is one. Again, I'm at the end of the day, so I ended up, I said, well, okay. So here we go. So what is the kind of risk that we need to take? If we are going to find new resources, new supplies of existing resources that have the kind of energy density that we have come to build our economic system around, we're going to have to take risks. We're going to have to go out into, for example, depths of water, like the BP Horizon well, in order to retrieve. Now, there's something very important about this. This is very successful engineering. There's not a whole lot of these wells that blew, okay? So from a probability standpoint, we got a lot of energy value out of this model of finding new usable sources of this particular commodity, okay? But the risk you need to be prepared to take if you are going to stay in this BAU is to have these, because if this, and why are we in that water? Why is the U.S. drilling for oil in 5,000 foot of water below sea level? I mean, everybody looks at this thing usually and talks about the environmental consequences, but you might ask, what the heck, why do we have this platform there?
We don't want to change.
Not only do we not want to change.
We ran out of the cheap sources.
Exactly right. The economist, exactly right. This is the least expensive, as we now know it, the least expensive method of bringing oil back into the domestic market. So if you're going to stay with this model, you need to take more of this risk. Okay? That's kind of the way it goes. This is another example. Again, if you look on the basis of probabilities of what's happened with the development of nuclear power, we could stay with the existing system. We can try and supply our way through the existing system. Peter probably made the better choice of staying away from this topic. Another way to deal with this, instead of fossil fuels, is to try, now there are a whole set of issues as to why this, including on CO2, but I'm just, it's a popular belief that we could use this technology. But you have to be prepared. If you are going to use more of this technology, even if, you want to talk about engineering for resilience. This is an unbelievable set of redundancies that were built by the Japanese into this complex. And of course, it did take a tsunami plus an earthquake and a set of problems that happened on site that we didn't anticipate. They weren't in the manuals. Nobody knew what the hell to do. And choices had to be made in the face of uncertainty, and the thing got out of control. Okay? But this is the kind of risk, again, that if you're going to stay with the business as usual, you need to be prepared to take more of this. Even if the probabilities, if we improve, and I'm sure we have, we are going to learn a lot from Fukushima. And we are going to design differently because of Fukushima, both existing and new. We're going to change that, okay? It will be better. It will be lower probability, but the more plants you put out there, as Weinberg said a long time ago, the grandfather of nuclear energy in the US, the more plants you build, the more accidents you will have. It isn't that the number of accidents is going to be large against the operating hours of plants, but you're going to have accidents, and you've got to be able to take that risk. Okay? The Japanese learned a very important problem that is, again, just the tie-up of what happens when your robust framework becomes fragile. They learned a very significant concern that was never, I know of no case in the analyses of accidents at other plants that ever came up. Because of the way the wind blew across Japan during the period of this accident, a great portion of Japan's agriculture was affected. The fallout from this accident hit a lot of the farmland, and Japan had to come up with a solution that's not a solution that you can do overnight or in a few days, which is, do we allow human beings to eat product from these lands? Do we, in effect, move the standard from what it is now in order to allow, so in the Soviet case on Chernobyl, this did happen. The meats that were in northern parts of Russia or northern parts of the Soviet Union were sold into the market, okay? It's a problem that you got to figure out what you're going to do, okay, in this. And the Japanese struggled with it. I think many believe that the Japanese have the best disaster management system on the planet, but it wasn't in the manual. It is a problem that you've got to figure out what to do. There was this hasty effort to figure out, well, are there some foods that we could allow in and other foods that we wouldn't? There was a debate about exporting the stuff. I'm just saying, those are the kinds of practical problems that human beings will have to confront as you move forward in making these choices. As I mentioned, there is no capacity to show any storm or any set of storms are the result of many of us are a little bit over 40 here, so our carbon emissions for the last, 50 years when you can't obviously indicate, and you can't build the kind of regional models yet that would say that the two hurricanes that rolled into from the Gulf of Mexico into Louisiana, into New Orleans, and caused this disaster to an American city. No one can say directly, but what you can indicate, and you're going to hear more about this in the IPCC's next assessment, is that the frequency of storms and the intensity of high energy storms appears, the database appears to indicate, well, it doesn't appear, it indicates that we are seeing more storms and more intense storms, and that would appear to indicate there's another risk that we're going to have to take, okay? Those are the risks, that you gotta. I want to mention a last one, which we've been talking about from lunchtime today. While natural gas and fracking has lowered the price of natural gas against what it was just a few years ago, there were projects, particularly offshore wind projects, that were being merited on the basis of an assumption that natural gas would hit something like $18, a 1,000 cubic feet by now. It's clocking in at $4, $5. Okay, those projects went away because of that change in gas. But what I would suggest to you be careful about is, because gas fell like that, don't make the assumption that your ride economically through this BAU scenario doesn't also carry economic risks. The evidence we have is that whether you own domestic fossil resources or you don't, there's a convergence from the amount of your income that you needed to spend on your energy bill as a country. This is the percent of the national income of each country or each group of countries that you spend on energy in 1997, and here it is in 2011. There's a convergence because the market is a global market, and you're going to ride a bumpier ride into the future where it's likely that a price trend is going to be upward, okay? Given that there are not other better options right now, you could say, well, I could pay more of my income for this purpose, or I could pay more for an energy source. So right now, the likelihood is that we're going to continue to ride on this, but it is still a very serious economic risk that we are also taking. Okay, so that's risk of not changing. So how about risks of changing? Probably the most important risk of changing, if you ask. So now I gave you that graphic about how we've got to hit 3.3 by mid-century. What would you have to do based upon current both economic data and technology innovation data and how we use energy? The IPCC tried to answer that with a graphic that looks something like this. By 2030, in order to hit that, we've got to scrub about 24 gigatons of CO2 out of our daily habits. Based upon economic modeling for this purpose, over 50% of it based upon remember the IPCC doesn't do original research, it's instead a synthesizer. It pulls research together and then reports on what is known. Based upon what is known, about 50% of that could be logically built out of improvements in energy efficiency, energy productivity. Another 30% out of sustainable land use and transportation planning. I think I'm not going to get into transportation today. Michigan has one of the bright light bulbs in transportation planning, and John DeSico back there. So I mean, you can just look around on campus. And then, of course, when we need to use more energy, that we're going to need to shift to non-carbon, low-carbon options. Now, Peter, I think, gave you very compelling evidence that if you're going to solve a problem like this, you cannot use a silver bullet. There is no such thing as I'm going to use solar to solve or solar and wind, or for that matter, solar and wind and no carbon-based. I just don't think you're going to get to 2030 and hit anything like this number without having to have a menu, and that menu must also include on the demand side and a significant reduction. Now, when someone who's trying to look at economic growth and has every evidence from an econometric effort to predict growth is saying, if you deprive me of this much energy, you're going to cause something, like an economic nightmare, this is an enormous risk, okay? From a sustainability perspective, this is how you read the speed bumps and the stop signs. From an economic perspective, this is, are you crazy? So this is I would say, the most important risk that we are facing in this regard. So if we're going to deal with the economic risk, if there is a collision between optimality and sustainability, as I'm suggesting, how do we deal with this economic risk? So now I would like to suggest to you that there are reasons for you to consider that this risk can be mitigated. It can be mitigated, and we can still get to that sustainable solution without causing economic disaster, okay? This is the case that I think has to be built, and if we don't build this case, I don't think this gridlock that we now have on economic growth and optimality against sustainability is going to be broken. And if that isn't broken, and then what I've suggested to you on the sustainability side has some merit, we're sending our grandchildren into a very unpleasant place. Okay, so can we reduce energy use? And can we reduce it without having significant adverse economic impact? So, end of the day, pictures to give you this. So we're coming off of the desert in Nevada to a city called Las Vegas. And over here on the left, you can't see it because we got too much light clutter in here, but there's a beam of light here. It's coming from the Luxor Pyramid, which is the commercial machine that has the most dense light shot into something that we have ever created, okay? And it's beaming out of the Luxor Pyramid. It represents the electricity needs of about 2,800 households living in Las Vegas, so you get a sense of, okay? And then you can ask what is the reason that we are putting this light into the atmosphere? What do you think? You think the planes could land without the light beam? Think they could find Las Vegas without the Luxor Pyramid? Why are we doing this? Peacocks, exactly. Exactly. Okay, and now get ready. I'm going to show you one hell of a peacock picture now. Okay, so this one you have to this has sort of heat to it. On a cold day, maybe it's good. So this is the main strip of Las Vegas. This is the outdoor lighting to try and help you find your way into buildings so that you can surrender some of your money to the local economy. This is the purpose. And what do you think? If you unscrewed 1 out of every 3 light bulbs, do you think people could still find their way into these buildings and lose money? Probably so. So only the peacock effect is what stands in our way, okay? We have to address why we demand something like this to convince us that it's okay to gamble.
How many of those are incandescent or other older technologies?
You know, John, I mean, it's a perfectly, so in a heartbeat we could swap out, a very large percentage. I just said just take 1 out of 3 just to, but and of course, if you look along here, this is another heretical question in the U.S. case. These red lights and white lights also indicate that, do you think there's another way to sort of drop us off and then pick us up after we've lost money, rather than all of this? So, but this is the kind of peacock effect that we're going to have to address. And so there's a lot of energy in this commitment, okay? Even so, even with this, so can the U.S. actually save energy without having economic calamity? Econometric efforts try to figure out, when you've got different inputs into a model of outputs that produces outputs, what are the more efficient ways to use those resources in order to produce those outcomes. And our own modeling, national economic modeling of the U.S. economy indicates that actually the U.S. economy saves, you won't see it just yet, but saves a lot of energy through the improvements in efficiency. These efficiency improvements sometimes come from technology. John asked, can we swap out one light bulb for another? We had a discussion on OLEDs at lunch. There's a whole variety of choices out there that we can use, but it also means changing the management strategy, changing how you use energy, when you use energy, why you use energy as well. Even with the American lifestyle the way it is, supporting Las Vegas because of the peacock value, even with all of that, this graph that we often use to say what energy is very misleading. This is the fuel mix that we depend upon, but it actually doesn't define how do we get the energy services that we need in order to operate this economy. In order to do that, you need to add an additional wedge besides the fuels, and that wedge is the improvements in efficiency that have made it cost effective for that kind of growth to take place. Okay? That efficiency measured, against 1970, these are the improvements that the U.S. economy through 2010 and then the projection out. We have embedded in what economists call the automatic energy efficiency improvement factor. We improve energy consumption by about 0.75% a year. Okay? That's before we even tried. Okay? And if you look at by 2035, this will mean that almost half of our entire energy services will come from efficiency. Before we tried, before we unscrewed the light bulbs, before we swapped out OLEDs, okay, and all the rest. So can the U.S. save a significant amount of energy? At least as a point of argument, I think the evidence is fairly clear that we can. This rate of improvement is with the same economic growth pattern we've had. If we can do it with this, and we can make energy less expensive and thus a lower part of our national income dedicated to it. Second question, when you have the need to supply energy, can we supply? And Peter took you through what is, I think, a very important argument about this, okay, which is when you go to renewables, remember it's low density stuff, and low density stuff means you may lose, okay, a lot of other things in order to try and get that. But I would like to make a point, okay, on that. This is an aerial picture of the city of Seoul with the Han River running through it. And one thing, when you look at this, it may not have occurred to you, but if you look at this picture, there is an immense amount of rooftop real estate that constitutes the area of the city. Those rooftops are collecting energy right now, not being used for useful purpose. In fact, usually the energy is being collected and then we're building mechanical systems to try and fight the heat that energy provides, okay, during the summer.
What city did you say that is?
City of Seoul.
Seoul.
I'm sorry, yeah, the city of Seoul. This is only a portion of the city of Seoul. This is the mountain. There's two large mountain parks in the city of Seoul, one here and one down here. There's almost another half of the city down here. It's about 12 million people, okay? So with the assistance of the Seoul Development Institute, we canvassed that rooftop real estate. We found out that it has, a nice handsome number here. So on the square meter basis, there's an awful lot of rooftop opportunity. This is the city's, at the time that we did the study, this is the city's energy requirements. All of this has gone up. We did not model high efficiency cells. We simply took what is on the market today, 20% efficient cells, and we threw out 60% of the rooftops in the city, either because they were angled roofs, because they were older roofs, or because they were shadowed roofs, okay? We did this through a statistical sampling technique to try and figure it out, but interesting result. The electricity that is, the energy that is striking the remaining 40% of that rooftop real estate could provide 36% of the annual electricity requirements of the city, and even more important, could cut the peak requirement of this city in half. This is a game changer. This is a way to shift a choice away from where we're now going on BAU to another option. So can we make inroads like this? Could we make this work? It is a small little problem of the cost. But as Peter pointed out, the competitiveness of devices, and I'm not trying to just sell you solar, I'm just trying to give you an example of how, in a highly urbanized setting, we can address this kind of problem. So, what do we need in order to get at something like this? A new economics. I love economics. I'd love to teach economics. I don't know how to change economics. A far better person than me, and Herman Daly, tried to change economics. He wrote the textbooks that could move us away from the optimality model to the sustainability model. We're still a long, long way away. So it may be that what we need to do is go after a sustainable energy economy and prove the merit of the model, okay? And then, hopefully, convince economics to rethink the problem. So, how do we get to a sustainable energy economy? I'm going to give you how we get to a sustainable energy economy, okay? We are now at a point in time very similar to what Peter said, in which energy is money. It is no longer cheap, okay? These bars, these thin vertical bars, are the retail electricity prices paid in different parts of the United States. Okay, so here we are in the Midwest, okay? The residents are paying 11 cents a kilowatt hour. The industry is paying somewhere south of 8 cents a kilowatt hour. If you look at the performance of energy efficiency programs in the United States, you can get an estimate of what is the cost to save a kilowatt hour rather than to supply. We've got about 12 years of data now on this. This is an all-in cost. This is not simply the rebate cost. When somebody gives you a rebate to buy a light bulb, you still have to pay the remaining price of the light bulb. You still, if you're a building and you have to get all of these lights changed out, you have to pay to get this installed, all the rest. This is an all-in cost that it typically will cost us less than 4 cents a kilowatt hour to save a kilowatt hour instead of using a kilowatt hour. This is where the sustainable energy economy exists. What about on the supply side? I'm tired of, I did a lot of these studies. I'm tired of trying to convince people as an academic about this question. So this is Lazard Bank. It's an investment bank. It has a menu of investors, and it advises investors what to invest in, okay? The energy portfolio is always important when you're talking with an investment bank, okay? The latest information that Lazard Bank has is that if you are an investor with my bank, we are going to advise you that the alternative energy menu is becoming competitive with the conventional energy menu. And you are better off putting at least some of your portfolio in the alternative energy menu than you are now. This is a very busy graph. I'd be happy to give it. Both folks can look at it another day, okay, and all the rest. Lazard's basis for its analysis suggests that a gas-fired combined cycle gas turbine, okay, this is with the lower cost of gas from fracking, will be, in terms of its levelized cost, this is an all-in cost, capital cost plus fuel cost plus operating and maintenance cost plus debt plus all-in cost. What is the levelized cost per kilowatt hour? You'll remember that technology that's always... So it looks like photovoltaics will be competitive somewhere, according to, not me, according to Lazard, somewhere north of 2016 and south of 2017, will be cost effective against grid, okay? That means that we now have an opportunity. We can take the savings that exist in energy efficiency, combine that with the use of renewables in strategic ways, and start thinking about, as Peter pointed out, it's going to take us decades to get anywhere near making even a small movement in the carbon releases in the atmosphere, but if we don't get busy soon. And the way that model is going to work is that basically you are going to use the savings from the grid, the savings because you're generating your own electricity at your building, plus you have a more efficient building, so you've driven down the electricity that you require to pull from the grid. And you're never going to invest in more than what the total debt cost of doing that, okay, would justify. That is, you take a mix and make sure that that mix is equal to the savings that you're going to get. That's the new security and the new sustainable energy economy. I would suggest to you that this word is not only a finance word. I'm going to take you now through finance. Sorry about that, but I'm going to take you through finance. It's not only a financial word, it's an economic word, and it's an environmental word. If you make this kind of model of improvements, can you then get the kind of combined security that sustainability is looking for? So I'm going to suggest to you that one last piece is needed. Marty spent a little time on trying to find institutional rules and signals. I would like to suggest to you that if we're going to make the shift toward a sustainable energy economy, you can't ask the energy sector that makes its money on you using more energy to lead the way. You're going to have to build new institutions. I don't think that these new institutions are going to be built by closing the 20th century. It performed well. If you please will remember how well New York did, okay, by this model, okay? Please remember, okay? You're not going to close them. You got to compete against them. So, crazy academics, we got the chance, first in Delaware, and then in Washington, D.C., and now we're in California, to create a sustainable energy utility which bundles together investors to invest only when and how much that increment of savings would, against your energy bill, would allow, and buy from a menu the most efficient options around. In August 1, 2011, the Sustainable Energy Utility in Delaware sold the first ever sustainable energy bond, entirely securitized by those savings. It was a $72.5 million bond. It merited these investments. There's hundreds of technologies that went into this. I often hear, we can't do this, people, the peacock. The moment that we made it easy for people to do this, the moment that we said to the public sector, state agencies, universities, we will have engineering companies come in, some of the biggest balance sheet engineering companies in the U.S. economy, Honeywell, Johnson Controls, Noresco, to come in, and they would now guarantee not energy savings, but dollar savings. They would guarantee enough dollar savings that the investments you made would always be paid off by the guarantee they are giving you annually through the period of debt service. Once we did that, we have not been able to beat them back with a stick. So I agree about studying human behavior, because I'm no doubt about it, but you also have to get the institutional rules right. You have to give people the chance to make this choice. And when they make this choice, big things happen. So, in a paraphrase on we went to the market, and I want to point out something important about this particular activity. We got a rating, credit rating from Standard & Poor's of AA+. Sustainability got a rating of AA+. Do you know what the rating is of the U.S. government? AA+. Is it possible? Now, this is a small state. In fact, with all respect, Marty, sometimes. So it's okay. Put as many. We have a very interesting solar program that I don't have time to tell you about today, but that we're doing through this SEU also. But Delaware can give you because it's so small, it can give you a difficulty trying to figure out scale. So let me give you a Michigan scale. Delaware only touched about 4% of the square footage of its public buildings and its universities. 4%. It led to a $73 million investment in those buildings. The savings overall is 26% reduction in the energy uses of those buildings. It combines solar energy, geothermal heat pumps, and this. We didn't do anything on transportation. As I said, you got one of the best minds in the country here at Michigan, so. Okay? What's that in Michigan terms? If Michigan touched 4% of its buildings, public buildings, and its universities, 4%, it would be about an $849 million investment. One transaction, $849 million investment, okay? Would the companies that did this deal in Delaware like to do it in Michigan? In a heartbeat. Why wouldn't you want to do this, okay? What was the big difference? What made them give the dollar guarantee? The SEU is a nonprofit organization which gives us access to tax-exempt financing. Tax-exempt financing means that the hurdle rate, the interest rate on borrowing, was about 3% over the average term length you could have seen up there was 13.4 years, and we had a total of a 20-year bond debt. We went deep retrofit. You can't get 26% by doing a low-hanging fruit. It'd be $840 some odd million for the state of Michigan if you did this kind of thing. That would be your first transaction. Can we build a market that will be in the billions of dollars, and can we get somebody to invest in billions of dollars? That's why we're in California now, because this model is, okay? So can it work? I really do believe that we can do this, okay? We'll go to market in the spring in Sonoma County, and we have a statewide program with California Statewide Communities Development Authority. If you give people the choices, this kind of model can work. But you have to first give them the choices. You can't ask them to make the peacock change, but tell them the way in which you have to do it is you have to go to the bank yourself and borrow up front all of the capital that will be needed to drive your bill down 26%. You would never do this in the case of the consumption of electricity. Suppose your utility said the only way you're going to get electricity is if you go to the bank and you borrow the capital cost for the power plant for me to send that energy to you. It had never happened. The way in which it works is you pay a monthly bill, and in that monthly bill you are paying off the capital cost of the investments that the utility made. You now need a utility that will give you the same deal. You pay your energy bill. It must be less than your current energy bill. That's the guarantee that these companies are giving you. And you surrender the savings that you get in order to pay off the debt. If you don't do that, it won't work. Borrow at 3.5%. The reason that these companies never do this in the market now is that they borrow in the taxable market where they have to pay upwards of 8 to 12%. Okay? And so all they do is change out lights because of that problem. Okay, so we got a shout out by the White House in 2011. We got a shout out by the Asian Development Bank. This is my closing, so I'd like to go back to how we do this worldwide. And to do that, I'd like to tell you a story from a recent trip that we took to India. And this is the hero with his wife. She wouldn't get in the picture, so this gentleman is an auto rickshaw driver, which is a three-wheeler that doesn't have a terribly good vapor trail to it. And he and his wife came up with an idea. They came up with the idea because for a brief period, the Indian government offered a subsidy on solar panels. It wasn't a big subsidy, but it was a subsidy. And he thought, well, what we'll do is we will take this solar subsidy up and we will put it to some use for a business that will be after my auto rickshaw driving during the day. So they went to their building and they asked the building owner if they could put the solar panels on the roof because they're renters. And we interviewed the building owner too, and the building owner said no. We can't figure out why, but the building owner said no. It wasn't a matter of money, because it was like, well, do you want to rent to put the solar panels on? Wasn't that. The building owner allowed them to stencil the solar panels on the front wall of the building. Again, we have no, unless the building owner was thinking, maybe I'll use the roof for this. We don't know. But anyway, that's what they did. And what was the product that they came up with? The product they came up with is, this is vegetable stalls in Bangalore that local farms are now selling their produce to office workers who are coming home and picking up the vegetables for the evening meal. And so these are the kind of vegetable stalls that you normally see. When you're trying to attract customers for this purpose, you should be able to light your vegetables. This was the technology of art at the time, a small liquid fuel lamp. In the background here are small CFL lights that are powered by a 4-cell battery that this family charged with their solar panels during the day, and they distribute at night, not the technology, but the service. They'll sell you 3 hours of light at night, okay, for this purpose, And the vegetable stallers can afford this. This is one of his clients. Very happily, they saw their business go up, and you won't see the liquid fuel lamp in most of these vegetable stalls anymore. This guy's entrepreneurship has led to a lot of other people now creating this kind of service. There's variants on it and all the rest. The point I would like to suggest to you is to get to a sustainable energy economy, we need to move away from the obligation to make the capital commitment all on the front end and have individuals pay for that, and instead build an economic system that will allow us to invest the savings, and through the savings, build a new kind of economy that will apply not only in North America, but in India and other parts of the world. And the challenge we have, these children, we are now working on their future. We are deciding what their future is going to look like by the kind of risk that we're willing to take. So that's my suggestion to you.